Hello students, it's time for the final part of the solar savings fraction calculation. We left off, we had just looked up on the chart and found that in this house, which was not very well designed, there was 3.5% of the home's heating needs that were coming from the sun. So what can we do with that? What does that mean? Well, the next thing we can do is we can calculate the auxiliary heat needed. In other words, what is the furnace going to have to do, or the boiler, or whatever you're using as backup heat? How much are they going to have to contribute in BTUs per year and also in dollars per year to heat this home? Isn't that amazing? Before you even build it, you can calculate what it will cost to heat it. So here we go. The auxiliary heat needed. Well, now that we know what the solar savings fraction is, and we've changed it from a percentage, 3.5%, to a number by moving the decimal place to the left. See that right there? From 3.5%, move the decimal place twice to the left, and it's 0.035. Now we're going to use it in this auxiliary heat calculation. That's number 5 on your handout sheet on solar savings fraction, which is under week 5, right? So we take the degree days, we know it's 6,500. We take the NLC for this home, which we know is 9763. And then we need to calculate 1, which stands for 100%, all of the heating needs of the house, minus what the solar is going to provide, which is only a measly 0.035. So 1 divided 0.035, 1 minus 0.035 is 0.976. See that little slash at the end of that line? That's because you're going to divide. What are you dividing by? 10 to the 6th power, or in other words, a million, because you have to take that into account. You want the answer in millions of BTUs. So take your calculator out. 6,500 times 9,763 times 0.965 divided by a million, and you get 61.2. That's how many millions of BTUs per year some other heat source is going to have to contribute, because the solar is not going to take care of that. Then we've got what's it going to cost to heat the building each year. So we start with the millions of BTUs that are going to be needed each year, 61.2, we just calculated that, times the cost of the fuel that was given to you is $6.30 per million BTU, and because we're in millions, that's fine to leave it as $6.30, and then divide by the efficiency of the furnace, which is given to us as 80%, also known as 0.8. Calculators out, 61.2 times 6.3 divided by 0.8, and we get $482 per year. That's what the furnace is going to have to provide. Now, let's look at what the dollars were per year that were saved because of the solar savings fraction. And in this case, it's not very much because it's a poorly designed house. But we take the degree days again, 6,500, times the NLC again, 9763, and this time it's not 1 minus the SSF, it's just the SSF itself, 0.035. We also have to divide by the cost of we have to take the cost of the fuel into account, right? So we have to multiply times $6.30, and you'll see how we divided there by a million to take into account that $6.30 per million, divided by the efficiency of the furnace, 0.8, and take your calculators out. 6,500 times 9763 times 0.035 divided by a million times 6.3 divided by 0.8, and look at that, only $17.50 a year coming from the solar. Well, not a very well designed solar house, especially when we know we can get hundreds of dollars a year in savings from using our solar game. Now this chart is here for you to explore. Take a look at which types of systems do better, which produce higher numbers, because that's the solar savings fraction in the center of this chart. The first line's the NLC, is the LCR, load to collector ratio, which is the net heat loss coefficient divided by the solar gain area. That's the first line. But all of the other numbers that are in this chart have to do with the solar savings fraction that comes from these different types of solar energy systems. So, have some fun looking at the chart and exploring it and learning from it. Yes, you can buy software and it will run all of these calculations for you and more. But isn't it nice to know what those calculations are and to understand the logic behind it? There's a question on the discussion board about solar savings fraction, and by reviewing what we've just done and looking it over, and also reading others' answers, you should be able to figure it out. So I hope you've enjoyed learning about how to calculate what percentage of your home heating needs can come from the sun. And remember, I've seen houses where it's 80% or more. So design it with that in mind. Design it with reducing pollution in mind, as well as reducing costs, and you'll have a house that you can be proud of in the future.